in an outdoor 125 amp panel being fed from a 480/240 transformer inside an adjacent building with feeder conductors and a neutral wire sized at number 6 THHN and lacking an equipment grounding conductor at the panel, the neutral wire should indeed be bonded to the ground bus terminal. This practice is rooted in the National Electrical Code, specifically Article 250.24 C1, which stipulates that the grounded conductor of a multi-wire circuit, identified by its white or grey marking, should not be connected to the equipment grounding conductor or any terminal or conductor intended for grounding or equipment grounding purposes. However, this doesn't negate the requirement for proper bonding under specific circumstances. The core reason for bonding the neutral wire to the ground bus terminal lies in maintaining both the neutral and ground conductors at the same electrical potential. This equipotential state is crucial for preventing voltage imbalances, which can lead to a variety of operational issues and, more importantly, significantly reduce the risk of electrical hazards in the event of a ground fault. A ground fault occurs when an unintentional electrical path is established between a live conductor and ground. Without proper bonding, this fault can result in dangerous voltage levels on metal parts and enclosures, posing a shock hazard. The process for bonding the neutral wire to the ground bus terminal involves several key steps that must be followed meticulously to ensure safety and effectiveness. Firstly, and most importantly, disconnect the power supply to the outdoor panel completely. This is a non-negotiable step to prevent electrical shock during the bonding procedure. Secondly, utilize a bonding jumper to establish a connection between the neutral bus terminal and the ground bus terminal. This jumper acts as the physical link that equalizes the potential between the two. Thirdly, ensure that the bonding jumper is tightened securely to both the neutral and ground bus terminals. A loose connection can compromise the effectiveness of the bond and create a point of resistance, which can generate heat and potentially lead to a fire hazard. Fourthly, once the bonding jumper is securely in place, restore power to the panel. After completing these steps, it's essential to verify the integrity of the bond and the overall system functionality. Several additional considerations are vital for ensuring a safe and compliant installation. The bonding jumper must be sized appropriately according to National Electrical Code Article 250.102. This article mandates that the jumper be rated to handle the current associated with the largest overcurrent device protecting the neutral conductor. In simpler terms, the bonding jumper's size must be adequate to safely carry the maximum fault current that could flow through the neutral conductor during a ground fault. Secondly, throughout the electrical system, the neutral and ground conductors should be physically and electrically segregated to prevent accidental misconnections. Misconnections can compromise the grounding system's integrity and create dangerous conditions. Thirdly, always use proper wire connectors and insulating tape to ensure a safe and secure connection. The connector should be rated for the specific wire size and material being used, and the insulating tape should provide adequate protection against electrical shock and environmental factors. The importance of grounding and bonding in electrical systems cannot be overstated. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to quickly interrupt the circuits and prevent damage or injury. Bonding, on the other hand, ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of electric shock. The NEC provides comprehensive guidelines for grounding and bonding, covering various aspects such as the size and type of grounding and bonding conductors, the methods of connecting them, and the requirements for different types of electrical systems and equipment. Adhering to these guidelines is crucial for ensuring the safety and reliability of electrical installations. In the specific scenario described, the absence of an equipment grounding conductor at the outdoor panel highlights the importance of the neutral ground bond. Without an equipment grounding conductor, the neutral conductor serves as the primary path for fault current to return to the source. Therefore, the integrity of the neutral ground bond is paramount for ensuring that fault currents can be safely and effectively cleared. It is important to note that while bonding the neutral to ground at the service disconnect or the first point of disconnect is generally required, bonding the neutral to ground at multiple points within the distribution system can create circulating currents and other problems. Therefore, it is essential to understand the specific requirements of the NEC and to consult with a qualified electrical professional when designing or modifying electrical systems. In summary, bonding the neutral wire to the ground bus terminal in the outdoor 125 amp panel is a necessary safety measure that helps to prevent voltage imbalances and electrical hazards in the event of a ground fault. By following the proper procedures and adhering to the requirements of the National Electrical Code, you can ensure safe and reliable electrical installation. In addition to the NEC requirements and the practical procedures for bonding the neutral to the ground bus, it is important to understand some of the underlying electrical principles that make this practice essential for safety. The electrical systems are designed to operate with a specific voltage between the energized conductors and the neutral conductor. In a typical 120/240 volt system, for example, the voltage between either of the hot legs and the neutral is 120 volts, while the voltage between the two hot legs is 240 volts. This voltage difference drives the flow of current through electrical devices and appliances. However, if the neutral conductor is not properly bonded to ground, it can float to a different potential than ground. This can create a voltage difference between the neutral conductor and grounded metal parts such as enclosures, conduit, and equipment frames. If a person were to come into contact with both the neutral conductor and the grounded metal part under these conditions, it could receive an electrical shock. The magnitude of the shock would depend on the voltage difference between the neutral and ground, as well as the person's body resistance. By bonding the neutral conductor to ground, we ensure that the neutral and ground conductors are at the same electrical potential. This eliminates the voltage difference between the neutral and grounded metal parts, thereby reducing the risk of electric shock. In addition to preventing electric shock, bonding the neutral to ground also helps to ensure the proper operation of overcurrent protective devices. When a ground fault occurs, a large amount of current flows through the grounding system back to the source. This high current triggers the overcurrent protective device, such as the circuit breaker or a fuse, to trip and interrupt the circuit. If the grounding system is not properly bonded, the fault current may not be high enough to trip the overcurrent protective device. This can allow the fault to persist, potentially leading to overheating, fire, or equipment damage. Furthermore, a properly bonded grounding system helps to reduce electromagnetic interference, or EMI. EMI is unwanted electrical noise that can disrupt the operation of electronic devices. A good grounding system provides a low impedance path for EMI to return to the source, thereby reducing its impact on sensitive equipment. From a practical standpoint, several factors can affect the effectiveness of the neutral ground bond. Firstly, the quality of the connection is crucial. A loose or corroded connection can increase the resistance of the bond, which can limit its ability to carry fault current and equalize potential. Secondly, the size of the bonding jumper is important. The jumper must be large enough to safely carry the maximum fault current that could flow through the neutral conductor. Thirdly, the location of the bond is also a factor. The bond should be made at the service entrance or the first point of disconnect. Bonding the neutral to ground at multiple points within the system can create circulating currents and other problems. The NEC provides detailed requirements for the size, type, and installation of bonding jumpers. It also specifies the locations where neutral ground bonds are permitted or required. Following these requirements is essential for ensuring a safe and compliant electrical installation. In addition to the requirements for bonding the neutral to ground, the NEC also addresses the requirements for grounding electrode systems. A grounding electrode system is a system of interconnected grounding electrodes that provide a connection to the earth. The purpose of a grounding electrode system is to stabilize the voltage to ground during normal operation and to provide a low impedance path for fault current to return to the source in the event of a ground fault. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The NEC specifies the size, type, and installation requirements for grounding electrodes. It also specifies the number and type of electrodes that are required for different types of electrical systems. In summary, bonding the neutral to ground is an essential safety measure that helps to prevent electric shock, ensure the proper operation of overcurrent protective devices, and reduce electromagnetic interference. The NEC provides detailed requirements for bonding and grounding, and following these requirements is crucial for ensuring a safe and compliant electrical installation. Always consult with a qualified electrical professional when designing or modifying electrical systems to ensure that all applicable codes and standards are met. Remember to disconnect power before working on any electrical equipment.